Alrighty folks, welcome to Programming in C++. My name's Mike and I'm going to be your instructor, and you can find the course by navigating to my webpage and clicking on Programming in C++ or scrolling down to the bottom to my previous semesters and finding the Programming in C++ course. So here it is, here's the course homepage. Let's go ahead and get started with Module 1. There's a course logistics video, the first video in the playlist, about how to get started as far as assignments and just how the course is going to be run. So hopefully it's going to be a pretty simply run course, but you'll get in the flow of things. And again, by the time you're watching this, it will be 1:30 Eastern PM on Monday, May 10th for this first video, and then tomorrow's will be released at 1:30 PM Eastern Time by Tuesday, and Wednesday, and so on. And sometimes these modules will open up a little bit early, but 1:30 PM Eastern Time on that day is the official start time when you can check out the model, click the video link, and so on. So let's go ahead and dive into it and start learning a little bit about C++. So just as a reminder, your deliverables, you'll have an assignment on GitHub. Again, you can watch that on the course logistics, and you'll have a graded in-class activity that you can click on here and take care of. So this first one is just a sort of simple survey for you, just to make sure you've read the syllabus and just gather a little bit of information about you folks. So with that said, let's go ahead and just jump into the slides here. All right, and let's talk about C++. Getting started, and we have a theme this semester. It's going to be programming in C++ one pixel at a time. I'll talk about what that means at the end of the course. All right, so I like to start off with a little pre-class warm-up, usually some fun fact here. And just kind of a fun fact here is that the C programming language, which some of you may have used, evolved originally from the B programming language. So not a very creative name. So naturally, C++ evolved from C because of its similarity. And the plus operator being increment or +1 was sort of a playful way to show that C++ was the next advancement from the C programming language. And C# has that same sort of fun play here where the sharp sign in music usually means a higher pitch, so it's the next sort of evolution of C++, or that was their sort of intent here. So you can read about the entomology there and the fun story about the language that you're going to be learning to use this semester. All right, so of course this is recording, you're watching the recording, and let's get through some administrivia. That's really our goal today, to just give you a brief introduction to the course so you know what's going on for the remainder of the semester, and I'll show you some C++ things as well. Okay, so who am I? Your instructor. I got into computer science a long time ago, just figuring out how do I make games. I think I was 12 or 13 years old, and I made this query, how to make games. And then I found out about all the stuff, the cool stuff, you had to learn the art, how to do music, how to program, and just slowly started teaching myself those skills to make some games. I enjoyed games and got bored eventually with playing them at some point and wanted to fiddle around and change them. So anyway, that's where my curiosity led me. And today I still enjoy games and still enjoy making games as well. So I started writing video games around middle school for me, and then writing tutorials for a gaming magazine. So if you look hard enough, you can find them on the internet. It's kind of funny to look back on. And I did my undergrad at Ohio State, a big school out in Columbus, Ohio. And that's where I sort of studied computer science, and I also learned about research. I learned you could do research in gaming to actually help people and do various studies there, and then got into medical visualization, which is one of my interests in computer graphics. And eventually somebody told me I should go to grad school. I didn't know what grad school is. Maybe some of you are thinking about that, and I'm happy to tell you about what a master's degree or PhD degree is, because I certainly didn't know. But anyway, found myself in Boston because I knew it was a great place to be for school. The Hollywood of schools, I would call it, I guess, with all the wonderful schools here, including Northeastern. And primarily since then, I've been doing work in sort of HCI, computer graphics, more systems-y stuff, and software engineering. And that's also where my professional experience lies, at these different places. It's been kind of cool. Pretty much all these places where I've worked as sort of a graphics-y systems programmer, and they've all been using C++. That's been the one thing that's very consistent. A little bit of C# here, or scripting here, and other areas, but always almost in C++. And then, of course, I'm a Husky now with you folks. Okay, so that's a little bit about me. I'm not the only one who's going to be involved with this course, though. We have a wonderful course staff. So if you look on our webpage, so let me go ahead and do that. Back here, you will see our course staff on the right. These are all great C++ users who will be able to help you along with the course as we get started here. Okay. We will introduce them, or I'll ask them to introduce themselves on Piazza, so you get to know them a little bit here. Okay, so with that said, I want to go ahead and just create a little icebreaker here on Piazza so we can start to get to know each other. And just record, your name, program, major, what you've heard about C++, and just get a little bit of interaction going on for this online course. Okay, so now you'll know about how to use Piazza here. And see how I just create this. I just go to the Piazza board, and here's my post. And you can put in any sort of category, and then post your note here, and there it is, published for the world to see. All right, so feel free to take place or part of this conversation here. And of course, throughout the semester, post anything on Piazza, which we'll talk about in a moment here. So while we're talking about that, let's go ahead and talk about our course goals and look at the syllabus a little bit just to get everybody on the same page here. So let's go ahead and take a look here. This is the web page as noted. If you ever get lost here, you can just Google my name and find my website, or just remember mshad.io and find the page here. So I'm going to go ahead and scroll down so you can see the syllabus here and make it a little bit different. A little bit bigger here. So you know what this course is about. You're going to learn how to use C++, but we really want to focus on using C++ as a C++ programmer would, okay? So we're going to learn some of the fundamental data types within the language and how C++ programmers tend to solve problems in a C++ way. So that's also going to be one of the themes for today's lecture, that it's not the same language as C. It's pretty similar for folks who have taken systems and done C programming, but we want to learn about some other things, okay? So we have some objectives about how to structure our programs, detect bugs, use a standard library, build data structures, and do a bunch of small programming projects. You'll actually see from the course schedule here, we just have assignments about 2 a week. We are in an accelerated summer. That's about the right pace, I think, before I sort of overwhelm folks with too much stuff. But this seems to be about the right cadence to me. For helping you actually learn and practice the things that we're going to talk about by building small programming projects. Okay, so with that in mind, let's continue looking through the syllabus. So the course map will roughly stay in this order. And as I mentioned, the modules open up the day of by 1:30 p.m. Eastern Time, our normal time. That's when you'll be able to see the recordings and so on. Okay, so there's a few resources. Most of them are free. CPP reference is sort of the very reliable way to look up, anything about the basic C++ language that you want to learn about and sort of explore those features. There's a nice C++ tutorial here if you prefer something that's sort of more like a book. You can always look at any of the topics here and follow along. That's a pretty reliable source. If you want a textbook, the two best ones that I found that follow this course and are just really good textbooks, the C++ for Game Programmers book. It's not specifically showing you necessarily game things, but showing you how to solve problems in the C++ language. The author says that this book will save you 10 years of your life in C++, and I actually believe that from this book. I've actually just finished reading it cover to cover. And it really is an excellent book. So it's a little bit older, 2006, but it's a really it's a hidden resource. It's really good. And then Professional C++, the 5th edition, has sort of the latest stuff. You can see I've recently bought it and I'm reading through it. It's a pretty good text as well. As far as coverage and being a modern book and sort of vetted by experts. Okay, so those are resources for the course. If you like, but you don't need anything, I'll usually provide enough free resources on the web as well. Okay, so about this course, academic integrity and non-discrimination, I don't think we'll have problems with these, but your integrity, we don't want to have any issues with cheating and stuff. I rarely have problems, and I think this is going to be a great group. And I want this to be a very collaborative class, so I'm fine with folks sort of sharing resources on Piazza, talking to each other. You just can't copy and paste each other's code or whatever. So I don't think we'll have a problem with that, but just something to keep in mind. The non-discrimination, and just in general, we want it to be a safe space. We are online, so things we say, we want to be respectful of our classmates. Again, I don't think we'll have a problem. I've never had any problems with this, but want to just make sure that feel free to ask lots of questions and share lots of ideas about C++ on the forum, and we'll kind of keep it to that. Okay, so the makeup policy, so you notice there were a bunch of assignments to complete. In the case that, you're just falling behind, Summer 1 does go fast. So you might be falling behind for two reasons. One, you might have a sort of university sanctioned event that is an exception. So if you're presenting at a conference, for example, or in a varsity sport, let me know, and that's an extension. But otherwise, this semester, we're going to be using a token system. Okay, so that is best explained by looking at our repository, where you'll have assignment 1 here. I'll get to that in a moment. But so you have these tokens here, and all you have to do is move them into a directory here. And if we see one of those tokens in this root directory here, we'll know that you wanted to extend your assignment by a day. And you get 3 extensions. You use them whenever you want. You don't have to tell me anything about them. And then there will be no late penalty applied to your assignments. Just move this file here and leave it there, and that's it. So you get those 3-day extensions throughout the semester. Okay. So you don't have to email me or ask for extensions, because then I have to make this decision and decide if I'm being fair to everyone, and I don't really want to decide that. I just want you to say, hey, I need an extra day here, and use it at your will. I don't need to know why. Always, and that's something we're going to experiment with this system. First time I've done it. I hope it'll work out well and be fair and sort of give you folks an advantage, if the semester is moving fast or whatever. If you've used all 3 of your tokens, then assignments come with a late penalty of 10% per day that they're not submitted. So even that's relatively small and reasonable, but there has to be a little bit of motivation to keep you on track, because the course does move fast. Again, I usually don't have problems with this for 96% of the students. If there is some reason you are really falling behind, then maybe we'll talk after you use your 3 tokens and figure out how we can make you successful. All right, so that's just about the lateness and makeup assignments and stuff there. As far as how you can be successful in this course, the Disability Resource Center is great at making accommodations. There's also WeCare to help you with any life challenges that might be going on. Feel free to utilize these. I believe they're free for you as a student, so take advantage. If there's something I can do to make the course a little bit easier on you or whatever, if I can speak more loudly or do something different, just please let me know, and I will try to accommodate that the best I can, so we can all be successful in the course. All right, lateness doesn't really apply since we're online, but in attendance, not either, because we're asynchronous. That means you can take the course sort of whenever you want. But I found that folks who are going to do well in the course typically are going to look up the lectures at 1:30 when they're released, or 2 or 3, or whatever time that is for you. Just set a regular time each day to watch the lectures and stay up to date. It can become hard if you decide that you're just going to cram everything in on Saturday. I can tell you the course is going to move fast enough that maybe the first week you're able to get away with it with some of our early topics, but by week 2 or so, it's going to be hard if you just try to cram everything into a day. So just keep that in mind. Do a peek at the schedule, and you can see that there's a lot of topics and things. Move at a reasonable rate for Summer 1. I'm keeping that in mind. But if you wait a long time to get started, that's going to be difficult for you. Okay, so please try to stay on track, and if you need help with that, just let me know. Just wellness stuff. Again, I just wanted to throw out the WeCare and health counseling. I remember being a student too, and juggling at times 3 jobs while being a full-time student, while being part of clubs. I know everyone at Northeastern's also very involved with stuff. So, if there is something, if this course is stressing you out too much or something else, just let me know, and we can also figure out a game plan for you too. Because the goal is to be successful. That's why I'm trying to give some hints and flexibility with things so you can be successful. All right, so that's on our policies. For assessment, this course, try to keep it relatively simple. Exams aren't really good use of time, I don't think, for learning C++. I think doing is the way that we're going to learn and building things. So you can see assignments are pretty much what this course is going to rely on. And they'll be equally weighted, so each one's worth the same. And then a little bit on each of the in-class activities. So you have one after each module. This is just to make sure that you're sort of testing your knowledge a little bit and capturing the main big ideas from each lecture. So that's the goal with the in-class activities. This is the scale as of now. I'll never make it harder. I'll never make a 97 an A, but I may reduce it sort of at my discretion. So it's always in your favor. I like to work with people instead of against them. So just keep that in mind. And then there's some general policies I'd like you to read through. You'll do that as part of your in-class activity, but every once in a while I have somebody who asks me if I can get an A in the first class. I said, yeah, you can earn it. But anyway, so that's, if you're wondering why some of these bullet points are here, it's because somebody's asked. Just notes on the lateness policy. So this is a heavily based programming course, which I think makes it pretty fun, but assignments that don't compile, we can't give credit for. So those go in the books as zeros. Typically, we're not that mean. Typically, we'll just email you and say, hey, you forgot something here. It wasn't compiling, and you might get a small penalty, but we'll let you resubmit. That said, as far as resubmissions and regrades, if you think we made a mistake, you have within a week of the assignment, when you got that grade, to challenge the grade. Now, regrades could result in a lower grade. Typically, we're not that mean, but just a word of caution that they're done sort of cautiously, just in case anyone on our course staff makes a mistake. Occasionally, it happens, but regrades aren't for redoing the assignment. They're for us to take a look at the work that you've already done and reevaluate it because maybe we've made a mistake or you thought something went wrong or whatever. Okay. And you just get to ask, whoever graded your assignment, you can just go directly to them and ask them. For those who are waitlisted in the class, that's a little bit of your gamble, so just try to keep up because Summer 1 is, it moves fast, so I'd recommend if you are waitlisted, you just try to keep up with the first week's material, and if you're really high in the waitlist, in the first or second position, there's a good chance we can get you in. All right. There's no extra credit assignments or none planned that are going to be built for us. So just keep that in mind. But in all my courses, if you really go above and beyond and do something cool in one of the assignments, we reserve the right to give you more points. That's how you'll earn your extra credit. I love seeing when folks go above and beyond on assignments or add new features that we didn't ask for, but that show that you're really, exploring and being creative and experimenting. That's fine. I try not to be that rigid. Let's see. In-class work you have to do within a week of that module. So today's in-class activity. If I go to this, here you have a week to take this. So 1 week from Monday. So by May 17th, you should complete this. Again, I recommend just doing them directly after the lecture. They're designed to be non-stressful and just to make sure that you've absorbed and watched the lecture and maybe thought about things for, 5 minutes or so. So that's a note on that. We don't have any labs in this class. They're just all going to be assignments. So that makes some of these points not as relevant. Of course, you can go on Facebook whenever you want. This is an online class, but I recommend when you're watching the lecture, you just focus on the lecture, take some notes, and try the examples in the slides, and so on. Okay. The last note that I'll leave here is that everyone needs to come and see me during office hours. It's not strictly a requirement tied to your grade or anything, but I like to see everybody, especially in an online course, so I can get to know you a little bit. This is a low stress meeting, I will call it, in which I typically just ask you your name, your major, if you've co-opted, what you're looking forward to in the class, some of these details. If you're talking to me later in the semester, I might ask you what you want to do in the class, what's been interesting. I try to keep it short, and then of course that's your time to ask me whatever questions you want. And I do it, one, so we can start to get to know each other, and two, just so you get used to going to office hours with your professors. I think that's a good thing to do in the university, because we can usually help you out in some way, and try to help you achieve your goals. Okay. So that's the Administrivia from the syllabus. Everybody's seen it and gone through it, and you know how to get here. Again, resources and stuff, you can watch the logistics video, but Teams link is where you'll visit for your office hours. Where are office hours? Click on this sheet, visit the week, and then we're on the C++ office hours here. You can go ahead and just sign up. We already got somebody who signed up. TAs will have empty slots sometime this week here as they figure out their schedules, and then you can sign up for those hours. And that's it. Then you just click on the appropriate link and it'll bring you in Teams for office hours. Okay, so with that, let's go ahead and jump back into our slideshow. And just to recap some of these things again, folks, you just need a laptop, which I'm assuming most folks have at their home, or a desktop. If for some reason you don't, let me know, or have trouble getting access to something, and we'll figure out, there's computers at the library and some of these things that if you're on or near Northeastern campus, you might be able to rent out. Just let me know. But any laptop's going to do fine for this course. You can use any platform, Windows, Linux, or Mac. Okay, and most of the stuff we're doing for the command line, so you can also do from the Cori servers, is also fine. Okay, the course text, as I mentioned, there's nothing recommended, but these were the two books. If you do want to follow along with a book and basically read cover to cover, a chapter or half a chapter a day with whatever the topic is another good way to get information for this course. But they're not required. I would have told you a few weeks ago, but these are the ones. Some folks like books, so these are good ones to go from. These were the other web C++ resources that I found reliable as far as if you want to learn C++ stuff. And I would go ahead and say that they're all very good. CPP reference tends to be the closest and most accurate to what is actually standard in the language. That's where most of the folks who contribute to the language are actually editing this wiki. C++.com, I don't actually know any of the people who own this domain, but the tutorials are pretty good. And I've found that the references and the examples in them are easy to follow. It's 99.9% accurate, I would say. I'd say C++ reference is your go-to. C++.com, if you just need a quick example of how things work, is good. For folks getting into advanced C++, ISO CPP, which is the International Standards Organization, has all the sort of latest and greatest C++ stuff as far as conferences. And then your other resources like Stack Overflow tend to be, fine as well for answering questions. Okay, my teaching style, just so you know a little bit more about me, there's going to be lectures, visuals on the slides, little in-class activities, so you can sort of learn by doing. Again, this is a hands-on class. We're going to build things. I want people to ask questions, make mistakes, experiments. That's all part of the learning process. And if you don't know something, ask, away on Piazza, office hours, whatever. That's just the best way for us to learn. That's the worst case for me is, I never remember who asked, a specific question if you think it's a silly question. I just remember that you asked a question and that you were engaged in the course. So that's what I look forward to doing with you folks here. So do ask questions. If it's asked a lot, sometimes I pause and I make a video about it in this online forum. Okay, since we're online, you don't have to worry about me randomly calling on students. I never do that anyways because I didn't like it. All right, so come to office hours and see me. My PowerPoints, these slides that we're going to be living in for this summer one, I'll occasionally pop in as well, but so you can see me. But they're probably not a good example for designing the ultimate PowerPoint, but I think they're a pretty good reference. I break all the PowerPoint rules to make these slides a resource that you can rely on. That's accurate. Okay. Email. So I get lots of email and I'm trying to always minimize it the best as possible. It's not because I don't like to hear from folks, but it's because I want course discussions to stay on Piazza so I don't double or triple answer a question. It's also helpful for your classmates. I think an active Piazza is a good sign of course as well. But anyway, this is my rant about email and the stats I get. So email is not a real efficient way to get in touch with me regarding the course content. If you have a personal matter, hey, I need a reference for a co-op. Hey, I'm going to be out on, it's my brother-in-law's graduation, and I really have to miss, the Monday class, and you tell me that, a few days ahead of time, those kind of things are things we can plan for. And you can send those to me an email. And I can sort of categorize those and get to those quick. But course-related questions where you copy and paste code in email doesn't do well. So Piazza is greater than email. That way, myself or someone from the course staff can also answer faster. I check my Piazza at certain times. I don't check it on Saturday just because I have to recharge and build the course material usually on that day. So just keep that in mind. Piazza is the fastest way to get in touch. Okay, tag me, tag all the instructors if you do a private post so we can answer a question, or if it's a public one, then obviously anyone can answer. Okay, so how to get help in this course. Piazza is great in a public post. You're going to also have a GitHub repository, so whether it's a public post or a private post, you can always share your GitHub repository there. And your repository is only accessible by you and the course staff, so you don't have to worry about anyone taking from it, okay? But if you have general, questions, hey, I have a link or error, I think there's a bug in the support code that I've provided or whatever, those are all good questions that we can take care of on Piazza. Okay. So again, office hours, attend early and often. Those are tips for how to get help in the course in Piazza. But if you're having other wellness issues or personal things, whatever, those are things that you can email me and we can have a private conversation about. Happy to do that. Okay, your expectations in this class, you have some prior programming experience. You're not jumping straight from, enrolling to this class unless you really have a lot of, previous experience in doing stuff. But most folks have taken at least Fundies 1, Fundies 2 to be in this class. So that's what I'm expecting. This isn't an introduction to programming class in the sense that I'm not going to explain what a loop is and make you draw a diagram and some of those things, but this is an introduction to programming C++. I want you to start to get a feel of the language. Okay, students who have taken computer systems might have a little advantage because you've seen C programming and you've managed your memory with malloc and free. So you might ease into things a little bit easier, but it's not required. So if you didn't understand a word of what I said, that's okay. You should just have used maybe a little bit of Java or, Dr. Rackets or whatever, and you should be all set for this class, okay? I'll assume most folks know a little bit of GitHub and stuff, but if you need help with that, those are great questions for Piazza, and that I can also, set up some support videos for. Okay, so my goal with this class is to prepare you to be able to use C++ on an internship, co-op, job, and so on. Just be excited about the language, searching for jobs for C++ programmers. In a sense, this course is a little bit geared towards folks who want to do stuff doing in games, graphics, high-performance computing, quantitative finance, quantitative chemistry, all these domains where C++ still sort of dominates those industries, and it's the go-to language. You can sort of figure out those things. If you search C++ on LinkedIn, you can see which kind of jobs are using them at different places. Maybe you get a nice salary here. That's pretty nice. But you can sort of get the idea. But at any level of the stack, what sort of fascinates me, whether it's your web browser, they use C++ behind the scenes. If you're using Chrome, if you program in Java, that compiler is implemented in C++. If you use Facebook, they for a time compiled the PHP script code down to C++. There's other stories of companies that just compiled their Python to C or C++. So you really can't escape the language, even if you think you're using something else, which is kind of funny. But it just goes to show you the power and the performance of the language, which is really cool. So, this is just a quick look at it, just to, motivate you a little bit that, you could be programming in C++ the rest of your life, right? There's lots of conferences and things also designed around this, okay? So with that said, let's go ahead and get started with a little bit of C++ history now that we've got the course administration done with. And this is the first thing I want to tell you. The theme of today's lecture is that C++ is not C. They're two different languages, so regardless if you know one, like C before, it doesn't matter. I'm going to expect everybody's looking at C++ for the first time. Everybody's on a level playing field here. And I'm not going to teach C++ like it's just C with classes. You'll hear me say that a couple times, but I'm going to do my best to teach you C++ as a C++ programmer, okay? It has a little bit of a different mindset for the tools that we can use, okay? C++ is actually a relatively nice language to program in too, despite what, it doesn't have to carry all the lore or the baggage of the C programming language, okay? It's its own language now. Okay, it's a little bit of history, and why people can't avoid teaching C sometimes is because, well, C++, way back in the 70s, borrowed from languages like C, Smalltalk, Simula, some of these other languages, but it was really built on top of C. So Bjorn Strusup, who you'll see here, who still works on the language, by the way, after 40 years, which is pretty cool. I've actually talked with him, so he's sort of accessible in that way. But the key idea was C++ would be C with classes. This is back in like '79, mid '80s. They built this compiler called CFront, which would just compile what we'll see as C++ into C code, and then use the C compiler to build the program. So that's sort of a little bit on the evolution. You could read about his excellent articles just about how C++ is used. I recommend this short one on C++ just to get a little bit of the history here. But the language, like languages we speak, evolves, so we have to treat it that way. And in the modern C++, which we say is version 2011 and beyond, if you can believe that, 10 years old, but that's the modern version, where we start from, is a very expressive language. It has a rich set of features. It has, things like lambdas or anonymous functions that you've used in functional languages. Those are into C++, which is pretty cool. Okay. So the C++, it has sort of its own philosophy, and I'm just going to paraphrase these things. They're also on the wiki, and they're found in that paper Bjorn wrote about the history of the language, that it's a really expressive language, and it lets you solve different problems without paying an extra cost. So if I want to solve things in a functional manner, that's not going to be more expensive using that sort of mindset or paradigm than doing things in a very procedural manner or an object-oriented perspective, right? The cost is going to be the same, and you shouldn't have to pay an extra cost for those features. So that's the idea, or one of the philosophies behind C++. Classes and using objects are also an important part of C++. The other thing about C++, just to highlight a few of these, is there's no language beneath C++ other than assembly, so you can sort of dive down if you want. But the other thing is, you have a lot of manual control in C++. And you're allowed to break the rules, but you have to be explicit about them. The language itself tries not to break the rules, okay? That's just a little bit on the philosophy. And we'll dive into these a little bit more to sort of really understand C++. We want to start slow, though, okay? Something folks kind of think about is, well, is C++ scary? It really shouldn't be. I don't know what the reputation is. I'm going to ask about it during the icebreaker, but, it's something that's new. Anytime something's new, it's, it takes time to learn, but that doesn't necessarily mean it's difficult or hard. I think those are sort of rumors that you read on the internet saying, oh, it's a hard language, use this other shiny tool. But I just don't think it's any harder inherently than any other language, and the context matters. Python, for example, or JavaScript is probably more beginner friendly, but the context matters, right? It's probably really hard to build a high performance video game or graphics application Python versus C++. So you can sort of, if you frame things that way, then it's like, well, what does hard really mean? Maybe it's harder to start, but that's what this course is for, getting you started. And I'd also say the other problem is C++ is taught in a sort of poor way. We don't teach the modern features. We don't teach it with using the standard libraries that give us lots of power and things for free. So that's sort of my opinion and what I'm going to try to correct in this course. Folks have sort of, when I learned C++, they taught it like they did in the 80s, right? And I took mine in the, 2010 or something like that. So it's, we've really come a long way, 40 years plus of knowledge and features that we can be teaching to make things less scary. So this course is my attempt to do so. So again, I don't want anybody to be scared. I hope this is a language you choose as your go-to language. Okay. I think motivation's everything for C++. That's just a wonderful language because if you think functionally or procedurally or object-oriented or more structurally or whatever, you can use the language in that way, and it doesn't penalize you for doing so. So it's a really flexible tool. The size of it can be intimidating. Let's get intimidated for a second. Let's look at this website. You go to it and there's all sorts of features and there's this whole wall of text here, but the reality is you don't have to use all these features. You can live in a small space here and just use a few features, okay? For the most part, even the assignments, I'm going to challenge you to use some structures because we'll be using, different things. Maybe I'll ask you to generate some random numbers or something using a library, but, you can solve problems with quite a bit of freedom in this class and with the language. So that's really the powerful thing about it, okay? The language lets you think at a low level, which I find helpful as sort of a systems programmer. You can be manipulating bits and you have that control that you just don't have as easily accessible in a lot of other languages. If you've got to use JavaScript to really do something optimal, it's hard. It becomes a hard thing in those languages. With C++, it's normal. Okay, and then you can also work at a high level, right? You don't have to do all these fancy things you might have heard of in other languages, meaning garbage collection and some of these things. You can avoid it. You can use C++ in a way that you never have to manage your memory. That's also accessible, right? You can rely on the libraries a lot that are included with the language to get work done. They can do lots of different things. Okay, so in this course, we're going to solve C++ problems, building data structures, graphical applications, optimizing programs, and so on. I want to give you a lot of creativity in how you do that, right? To use the language. That's the goal here, that you would leave this language or this course knowing the language well enough to, get an interview and get an internship and these kind of things. Okay, so with that, let's go ahead and get started. Let's look at the language here a little bit. Okay, so hello world, this is where it all begins here. And some of these I actually want to code up as we go along here. So you'll see me pop up Vim and Tmux here to sort of split the windows. You can use any editor you want in this class, but let's go ahead and do our hello program. I've already got one written here, so I just want to write it along for you. So every C++ program has an entry point. That's a main function, and it can take in arguments, the argument count, and any argument values. Typically, I just omit these, but this is sort of the pattern here. We need libraries so that we can do stuff. So IOStream, this is the way that we output text in our programs. And this is part of the standard library. So you're going to see a bunch of statements with stud : : that say, oh, you want to have all these different functions here that are included in the language once I include that library IOStream here. Okay, so let me close that out. So what do we want? C output, so that's going to write out output to the terminal. I'll say hello class as you're watching this, an end line with a backslash, and I will save this file. And if I want to compile it, let's use our G++ or Clang++. Those are the two popular compilers we used. I'll stick to G++ for now. We're using a modern version of the language, so the standard that we're using, we can specify that, or by default, I believe this uses a relatively new version, so that's fine. So let me just give you the bare bones here that we're compiling hello CPP. We want to output this file as prog. If there's any problems, they'll pop up here. And I just do /prog to run and hello class. So you can follow along with this on the Cori servers at this time. Try typing in your first C++ program. It's a great exercise. And what you'll notice is C++ is a compiled language. So if I want to make a change, hello there class, if I save this and I run the program, it hasn't updated. I have to recompile it after saving the file and then rerun it, and then you'll see the update, hello there class, which reflects the change here. So that's the first thing to know about C++. It's a compiled language. That's how we use it. So as you make changes. So I like to make very small changes and recompile often. I think that's a good practice to have, okay? With that, anyway, that's our hello world in C++. There are comments here, lines that start with // so just like in Java, if you've used Java, same commenting style. You can use the // or the slash with an asterisk to do multiple lines. Okay, so here's how we can run the program. And I want to show you something else because I really want you to look at these examples today and try them out. Pretty much every example has been prepared so that it fits in a slide. If you want to get access to these, you can go to the code samples, the repository here. We're in module 1, and you'll see all of these examples here. And the associated @ file here, hello.cpp, is that file here. So let me just go back here. So if I find hello, this is the file from the samples. Okay, so that's where we are there. There's some other cool tools. There's Replit if you want to follow along just in your browser. And there's another tool called Godbolt that's also really good, where you can just type in these examples online here. Here, let's just do a simple one like this with our hello world. I just want to show you how to use this tool really quickly. So if you're like, I don't want to bother with the terminal, you'll have this example here. So it'll actually show you the output here as it's compiling in the assembly. You can hide this if you don't want it, like so. Just make this a little bit smaller here, and then you can actually see the output here. Okay, so let's see. I need to do more. Let me just reset the layout here. And then I can click on the output, compile it to binary, and then run the compiled output. Let's see here. And the output, oh, I need to make some changes here. Into main, turn 0, standard cout. I'll make this a quick one, hi. And we need a library for this, so it's going to warn us. The warnings are usually pretty helpful. It said, hey, you didn't include this library here, but then you can see the output here. So I really like this tool. In fact, I'm going to dedicate a slide to this. Follow along in these examples by typing them in Godbolt. Okay, just so you have them there. And I think that's a fantastic tool. It's called the Compiler Explorer. Godbolt's the last name of Matthew Godbolt. It's the coolest last name ever. I'll probably talk about him later in the course. But anyway, so that's how to follow along with these examples. As I do them today, it's going to be a flurry of small examples like that, okay? So again, just explaining what's going on. We have our compiler. We can sometimes put in the version that we want of the compiler. If you're using Godbolt, you can specify the compiler options here. For example, you probably won't have to for most examples today, but again, we like using modern C++, so that's 11 and beyond. So it's like 14, 17, every 3 years is when they come out with a new standard. 20, some of your compilers might support, and that's how you run the programs, okay? Okay, so in brief, the compilation process, we bring in this C++ file. It follows the same pattern as in Java, or if you've seen this in my systems course. You take in the file, it goes in through what's called the preprocessor. So anything where you've done that # include. So for example here, #include IO stream, that's going to say, hey, wait a moment for us to copy and paste essentially this file here, IO stream. It usually ends with a .h. We'll explain that in a little bit. Just copy and paste it here so we have access to all these functions here, like cout. Okay, so the file gets expanded. Then the compiler takes that in and generates an assembly code. Okay, what's assembly code look like? Well, you can use the Godbolt tool and you can actually look at it. This is what's generated in between. If you look carefully or sort of follow the colors here, you can see what things map to. So if I find something in this light yellow, that's this call to some library function and moving some stuff around here. So that's what's going on there. And then eventually your program, your executable, is generated in something called a .o file. Any libraries, such as the standard library functions like cout, are then brought and linked in together into our program. Okay, and that's what we're actually running prog here, /prog. If this sounds confusing, don't worry. We will dive more in depth here. But again, I just wanted to show you that this is a compiled language. Okay, and voila, that's how you get your hello world. So please try that at least on Godbolt, preferably on your own terminal at this point. Okay, so pause the video and take a moment to do that. Okay. Okay, so the takeaways again from the Hello program is C++ is a compiled language. That's great for performance for us. Code can be executed faster than our interpreted code. Which is the language like Python or JavaScript. You can take these benchmarks for what they're worth, but this one's showing it's 10 times faster. Okay, of a language. That's pretty cool. By just using this language, you get to 10x performance speed. That's something you can't really do in a Python or JavaScript or whatever. Okay. The compilation step too, it seems to slow us down, but it can actually be a valuable thing for us as programmers too, to catch errors while we're compiling our code versus at runtime. So that's actually a good thing, in my opinion, to use a compiled language and have that additional, before your code runs, be able to check for errors and do different analyses on your code. So we'll talk more about that as we move along here. Okay. One thing to keep in mind, there's something called a namespace. That's just a way to organize our code. So I can type in using namespace std, that's how it's pronounced, std here. And then you don't have to type in the std : in front of this cout here. The namespace says, where is this function located? It's kind of wrapped in this namespace. And that just saves us some typing. I like typing it out, so you'll rarely see me use this here, because I want you to know it's coming from the standard C++ library, standard or std : cout. All right, just a few other notes on C++ compilers, since we're working in compiled language. This is what's doing the hard work. So here's just another visualization of what's going on during the compilation process. If that other illustration wasn't clear. And these are the things that we're going to do in this class to sort of optimize our code or make it run faster with different compiler flags. So if you've explored those, that's great. If not, we'll talk about the different sort of optimizations our compilers perform. Okay, just a little trivia if you want to think about it, but what's the difference between a release build and a debug build? I wonder if you've ever heard the phrase. If you haven't, take a moment to pause the video and maybe look it up. If you're joining us again after pausing the video, the answer is, debug build has debugging statements. We're going to talk about debugging very soon here. And it gives us extra information in our program while it's running, versus the release build is the thing that, when you download or buy a program, you're getting the release version that doesn't have any additional debugging statements or information. It's going to run a lot faster. Okay, so we'll talk about those things here. Okay, and then finally, as far as what the compiler can do, and we'll be revisiting this, you can click on the different standards of the language to see what features are enabled if you want directly in C++ reference. Sometimes it'll tell you what features are enabled based off of this page here. Okay, so that's a good resource, again, to check out. All right, so at this point, we've been going for a while, and if you need a break, well, it's an online course. You can take a break whenever you want, but I like to put these little breaks in here just to remind you to, revisit, try some of the examples before moving on. All right, and if you're joining us after that break here, let's work through some C++ quick examples here. Okay, I'm going to go through these relatively quick, but I want you to try them out. They're all in the GitHub here. But C++ has a bunch of built-in data types, right? Machines, computer science is all about, putting things in data and manipulating that data. So the different types like chars, shorts, ints, longs, etc. And we even have bools, which is just a single bit. typically to represent our data. So here's an example of the different primitive types, and I believe I have these already coded up. So I want to at least run the example. You can look at the code on the slides otherwise. Go into our CPP directory, into one, and this is the data type. So let's see, G++ here, data type. And you'll notice these files, there's a few more lines above it that tell you how to compile it. So you can look in the repository for that. So this one compiles and runs, which is great. And oops, we need to be in this directory. Let's do this here. And you can see the different sizes of each of these data types in terms of how many bytes there are. So the size of is a way to figure out any of these data types, how big they are. Okay, handy operator there. Let's see, to the next slide, there's other types for more precision too. So we're not just limited to those types, right? C++ is an extensive language. So we have, I did the ones up through 17 here. Oops, actually we need C++ 17 here. Do that. So occasionally you'll see me make errors. I like to leave those in the videos so you can learn from them. But here's some other types. So there's a standard just byte, which is just 1. Or you can say, hey, I want an integer, but it's only 8 bits. So that's 1 byte. Or maybe 16 too. And these are really nice because you're specifying, regardless of the architecture, exactly how big this type is. This one here is a little bit weird. We'll talk about it. It's a pointer. Pointers store addresses, so we're going to have a dedicated lecture to that, which can point to other things, and we need 8 bytes for that in a 64-bit architecture. Okay, so we'll talk a little bit more about that. And here's just a 64-bit integer that gets bigger, and then you can have really precise decimal values if you use something called a long double, and that takes up more storage space. Okay, so that's the idea behind these examples here. Okay, so here's another example here with const, and depending on, oops, let me back up one slide here. Depending on the language that you've used, you might have heard this term about immutability. So here I'll highlight here, the value of pi is something that shouldn't change, so you can make it constant. So then if a programmer tries to change this value, you'll get an actual error message here. So let's go ahead and let's compile this one, const here. And I'm just going to call these prog here. And the value can never change. Let's try to change it. Let's be a little bit evil here. Let me navigate to this directory here. So let's say if I try to change it, just so you can see the error message that shows up here. If I try to redefine it, what's going to happen to a constant value? Let's say it's actually 1. That's no good. So I saved it there. And let's try to recompile it. Const, put it as prog. It'll say this is a read-only variable. That means it's immutable, or we can't change it because it's been defined as const. Okay, I'll do that change, that evil change. Okay, so the thing to note from this is C++ is said to be statically typed, meaning once I say this value is a const float pi, or const float, it's a floating point value that'll never change. It's read only. At compile time, that is the decision that it's going to make. That's how it's going to evaluate the rest of the code. So it's statically typed. You know, I can't just say pi all of a sudden is a string or some other type. It is what it is. I can treat it. There's a way to treat it as a different value by casting it, and we'll talk about that later. But once I declare that this is a float and it's a read-only float or an immutable value, that's what it is. Okay, so const is an additional qualifier. We can actually put it on either side of the float. I like putting it on the left side, but it can't change, okay? Const is going to become very useful when we talk about concurrency. Okay, C++ has arrays like other languages do. And they can be used and created like in C. So I'm going to just create an array here of 5 integers and assign values at the index. We count from 0 here to each of these values here, and that's it. Okay, the same way you do things in Java as well, or similar. But in C++, we're going to have a lecture dedicated to this. In the standard library, you have an actual data type for an array here. So in the same way, I can create an array of integers in 5 of them and use the standard library. Now, what does this give me? So I can show you an example here, the std array example, where I have an array of 5 things, and then I could call this member function. In Java, you know this is a method, dot on this variable named arr for array, and fill it all with values of 7 without having to type in a bunch of stuff. Okay? And then I can access it like I normally would, the third element, or there's actually helper member functions here. I can just do dot at 3. And dot at 3 actually does additional bounds checking to make sure I have at least 3 elements in this array. You know, if I passed in 300 here, it would give me a warning or an error message at this point. Okay, and then I have other functions like size here. So I can do dot size and I can actually retrieve the size, whereas I can't do that with the sort of raw array. So that's something, again, using the language as a C++ programmer would, we would prefer to use std array. Okay, so those are some of the things that I'm going to teach you in this course. The language has loops, so here's an example of looping through that array and printing out all the values at the indexes here. So we can proceed from there. And it also has range-based for loops. Okay, so that's another way to just iterate through a container structure in a sort of range-based loop here. Now this one's a little bit different. We have this auto here and an ith element and through array here. So all the contents here, and we can print those out. Okay. All right. And then finally, we have while loops here. Okay, after looking at our range-based loops, this is a way to iterate through our code forever and forever. Let's go ahead and run this example here. And let me just open up my terminal here. And let's take a look at our while loop here. So while, TPP, etc. Make this a little bit bigger so it fits nicely on the screen. And let's rerun this, G++, while, and output it as program. And you'll notice this just runs forever. While true, run forever. So all the conditionals that you can use in other languages like Java are supported here. I could use a greater than sign, less than, or whatever. But if I'm stuck in an infinite loop here, which this is running forever, I can just hit Control-C and terminate the program. So that's what I want to show you there. Okay, so that's the while loop. So I've given you a bunch of examples, so let me walk back through them, and I'd like you to try those. Try them in Godbolt, try them on your terminal just to get used to them. Try typing them out. That's how you'll sort of build your muscle memory and experiment. And I think that's a good number to try for today before we proceed on tomorrow here. But before we end, I want to end with something to get you a little bit excited about the course, our course theme here. We're going to be doing things 1 pixel at a time. So you're going to see starting around assignment 4 technically, but around 3, we're going to start doing a lot of graphical demos. So here's a couple that I've prepared for you. We're going to do some image processing, a little ASCII art. This will be our 3rd assignment. A little falling sands demo, creating fire, and some dynamic effects. It's a really nice way to see what you're programming to as well. So this is going to be C++, 1 pixel at a time, and we're going to learn some fun algorithms. These will be great. It's always great to learn something in a domain as well, so with context. So that's what we're going to be doing. I think it'll be fun. I hope you'll be excited about that. Okay, so again, go ahead, try on REPL.it or godbolt.org, all those examples just to start building up your C++ here. You can use your favorite terminal or IDE or whatever. Your first assignment is released. You know basically enough to get started and complete it. So feel free at any time to begin. And don't forget about your in-class activity otherwise. All right, and that's it. And we will talk to you again tomorrow when the next lecture is released at 1:30 p.m. Eastern Time.